Hello, my name is Anne-Marie, and today I'm going to teach you about the science of Sharknadoes. Not really, although I do think that would be interesting and we should look into that. No, today we're going to learn about something much simpler, the space-time continuum. Space-time is fascinating because it's pretty much the basis of our universe, but most people know so little about it, even in its simplest form. So that's why today I'm going to teach you about space-time. What is space-time? Well, space-time is the name we give to the relationship between space and time. And space is usually regarded as having three dimensions. Think length, depth, width. Or if it helps, think the x, y, and z axis on a graph. And we consider time to have one dimension. So this combination is four-dimensional, and we call the four-dimensional combination a continuum. And no, it's not 4D like the 4D rides at Disneyland where you wear 3D glasses and they spray you with water. But it's a little bit like observing someone on that ride. To think of time as a dimension, remember that none of the dimensions can operate independently from each other. You can't just have depth, you have to have something that has depth. So think of time the same way. Time allows the third dimension to change, and through the direction of time, we're able to observe changes from state to state. To better understand this idea that space and time are connected, think of the universe like a flipbook. We perceive each page to be a moment in time, or an event. And us as humans, our perception is that time moves linear in one direction. But perhaps that's not the case, because the flipbook is already all here. Or it might help to think of the universe as a regular book, where the beginning, middle, and end, past, present, future, it's already all there, but we only read one page at a time. There are many images that try and illustrate this combination of space and time into one, and this is a common one. But it's hard to understand because we as humans aren't used to seeing anything with four dimensions, and we're certainly not used to seeing time being its own dimension. Most people attribute the discovery, if you will, of space-time to Albert Einstein, based on his theory of relativity, which changed the world of physics. But it was actually one of his professors, Hermann Minkowski, aka Original Hipster Mustache, who looked at Einstein's theories and realized they couldn't make sense if space and time were separate constants. They had to be connected somehow. And that's why we refer to space-time sometimes as Minkowski space. Going back to Einstein's theory of relativity, space-time is actually personal for each observer. So, let's say there are two lighthouses 50 miles apart, and I'm on a boat directly in front of one of them. The lighthouse keeper turns the lights on at exactly 8 o'clock. Now, the light from this lighthouse that I'm closest to would travel to me faster, so I would see it light up before the other one, because the light has to travel farther to get to me. But for the lighthouse keeper, they would both turn on at the same time, and it would be a simultaneous event. But I perceive it as two completely different events. So that's how space-time can be personal, and each person can see it differently. Another way to visualize space-time was offered by physics professor Stephanie Durant. And in this demonstration, we see an event happening in time. So an object moving back and forth, and eventually splitting into two. This slit is time and how we perceive an event. Time going in one direction and the event happening. But if we take a step back and look at the object's space-time, we see this, which shows everywhere the object went. By looking at this, we are stepping out of time and space being their dimensions, and we're observing them together. Remember, space and time have a four-dimensional relationship called the space-time continuum. This is important because understanding this means having a better understanding of how time and our universe works. And knowing that even though we as humans perceive time to be a one-directional, rigid constant, through the mathematics of space-time, we know that it's much more fluid and dynamic. And this knowledge, I believe, will be the key to traveling thousands of light years into our universe, maybe into the past, and perhaps even into the future. And all without Doc Brown and a DeLorean.